So let's move on. So the second part is machine learning algorithms. So again, this is with other instructors and prisoners. And we went through the objective bootcamp, introduction to machine learning before learning our ML algorithms, that is cross-validation and confusion matrix. And the main part of lecture 2 is supervised learning, unsupervised learning, and reinforcement learning. So how I organize this lecture contents too is I'm going to introduce these basic algorithms, falls into supervised, unsupervised, and reinforcement learning, and then give you some example from my own domain, which is a building energy. So I think the building energy domain is quite easy to follow because it's our everyday life. So algorithm theory and then building energy example. That's my concept on those explaining these algorithms. In lecture 3, we'll use the building energy data for learning classification algorithm using KNN and decision tree. So because I'm going to cover KNN and decision tree in this lecture contents too, so and the lecture content 3 is basically you utilize this KNN decision tree knowledge into actual Python coding. Okay. So supervised, unsupervised, and reinforcement learning. Anyone heard about these words before joining this lecture? Anyone? Supervised, unsupervised, and reinforcement learning?
Getting a few no's in the chat.
You know, in the chat, okay. All right, so let's begin. Now you hear about this term. So this is basically two main classification of ML algorithm. People say supervised learning and unsupervised learning. And reinforcement learning is kind of combination or mixture of the two. As the name implies, supervised learning is something supervised, something you need to have as a rule or as a label. So you need to have the output or label to learn. On the other hand, unsupervised learning, there's no label. It's unsupervised. Nobody supervised the outputs or label, but it just gets the input patterns. So learn the patterns in the inputs. That's clustering. So supervised learning, learning mapping from input to output. The main difference here is the output here. Okay. So output, this is a main difference of supervised learning. For the supervised learning algorithm, either it's a classification or a regression, you need to have output so that you can map or you can learn the mapping between the input and output. On the other hand, unsupervised learning, there's no output. It only contains the input, but the machine learning algorithm will learn the pattern in the input. Normally, we call it clustering in the other name. The reinforcement learning is learn to act from rewards in the absence of examples. So it's more like a decision-making processes. Okay, so we'll go over the reinforcement learning later on. But this is a main idea of classifying the ML algorithms. Any question on this point? Everything good?
Don't think I see any questions.
All right, so let's move on. So let's start with the supervised learning. So as I said,
এ
You
থেকে
must.
L পর্যন্ত তারপরে B.
What was that? You good? Okay, so supervised learning is you must have labels, outputs, targets, and the modeling the relationship between features of data, some label associated with the data. Once this model is determined, it can be used to apply labels to new unknown data. Okay? So let's say you have all the like weather data from previous days. If the relative humidity, if the temperature of your backyard is this amount, then it will rain in tomorrow or rain in 6 hours later, like that. Then you learn the model based on those weather station data. Then you can apply this model to predict either there will be rain or not for your future scenarios. That kind of is supervised learning. The very important point is labels or outputs. In supervised learning, there's a two classification again. One is, here's another classification. So there's two types of supervised learning. One is a classification and one is a regression. Okay? Can anyone differentiate between classification and regression? I'll bring my water bottle, so please type your ideas. What is a classification and regression while I'm bringing my water bottle, okay?
Yeah, from what I understand here, classification is separating items into different items that looks alike, you separate them from one another. While regression is looking at the relationship between items, how what they have in common, how they interact with each other. If there is if one item is influencing the other in one way based on the property.
Okay. Any other opinion? If you have, please type in. I will bring my water bottle now, okay? Okay, I saw one opinion from Daniel Gomez. Regression is the average. Okay, and I saw the hands up while I'm moving the one. Can you try? Yeah, okay. More related to features, data regression related data as it is. Okay. Regression is the relationship correlation between two data model. Okay, Akshan. Thanks everyone, your inputs. Okay, classification is putting outputs into different sets, while regression is expected pattern. Okay. Fully classification, grouping, regression, continuous values. Oh, okay. I think Holy, you got the points. All right. So classification is more like a binary or the classes that you want to classifying it. So for example, if you want to like predict either rain or not for tomorrow, that's classification. Okay. On the other hand, regression is more on the continuous and numeric value. So for example, how much will it rain? Or how much it will snow? That's more regression. So if it contains the numeric value. So on the other hand, you will pass the exam, pass or fail. Is that classification or regression?
Classification.
Classification, right, Joel. How about your grades on ABCD? Is it classification or regression?
Classification.
Classification, right. How about your exam score? Like 1, 2, 3, 4, 5, 6, 7, 8 until 99 and 100. Is it classification or regression?
Yeah, classification.
No, that's
I think
regression.
regression.
Go ahead, Aksha.
I think it's regression
Yeah, why do you think it's a regression?
because it's a continuous. It can be from 1 to the maybe 99.
Yeah, numeric values.
Numeric.
Okay. Yeah. So how about your temperature tomorrow on your city? How about this, Joseph?
Mhm.
Temperature. Is it classification or regression? Temperature tomorrow, your prediction.
Future prediction.
Yeah, it's a prediction, but it's a classification problem or regression problem?
I
Yeah,
think
I
it's
think it's
regression.
regression, yeah. Because
Yeah,
it's a prediction.
right. And prediction on the numeric continuous values.
Okay.
You got it?
Okay.
How about, can you come up with the classification then? Or regression, sorry, Joseph. One example about regression in your domain, in your environmental engineering domain.
Like we can say the stream flow value,
Mhm.
like 100, 200 milliliter per seconds and stuff like that. Otherwise,
Yeah, that's good. That's good. And for example, like let's say your like from the sales domain, like how much income or the net positive like from the sales on your company, is it classification or regression about dollar amount? Your next year net income, is it classification or regression?
that's a regression.
Yes, regression. Right. Everyone clear on the classification and regression?
Someone had a question in the chat asking, is it regression because it's taking the past data into account for future predictions?
No, Daniel. So it's a regression because our prediction is related to continuous numeric value. So we are all taking into account the past continuous data, but the important thing to kind of differentiate between prediction and regression is what is the output? Okay. If the output is like ABCD or true or false, or do or not doing it, or like some categorical value, then it's a classification. But if our output is more numeric, continuous numeric value, then it's a regression problem.
Okay, continuous.
Yeah. Did you get it, Daniel?
Okay. Outputs.
All right. Let me continue. So the first algorithm that I'm going to introduce in the classification supervised learning is KNN. The full name is K nearest neighborhood. The intention of selecting those algorithms is simplicity and easy to learn, because I like to make you guys all interested in machine learning and further study on this machine learning topic. Okay? So here's the input data set, which is a blue. So you have no idea what is the label of this blue. Okay? You have to check out 3 if I put k equal 3. This is a parameter that you need to decide. You check out your nearest neighbors, which is this, this, this. From your general thinking, how should I classify this blue unknown? Either orange or white? Yes, try.
Say that again.
Yeah, so let's say this is you, okay?
Okay.
And here's your close friends.
Mm-hmm.
And one person, I like soccer.
Mm-hmm.
And 2 other friends says, I like basketball. And you
Mhm.
guys are same kind of educational background, and everything is kind of similar. How should I say you like soccer or basketball? This blue input is either white or orange.
Oh, orange. Okay.
Yeah. Is it orange or blue? Oh, orange or white?
I think it's orange.
Orange. Why?
It's near to me. I think it's near to blue.
Yeah.
I'm not sure.
Yeah. So let's say using this way. This is a y-axis. This is
Mhm.
x-axis. And then x-axis saying air temperature. Y-axis saying relative humidity. And if this is like rain or not rain, I don't know. I just made it up. This blue points is highly likely following these orange dots, because very similar pattern data input, they are doing the orange input, right? So your unknown blue should be orange. That's the main idea of KNN. So you have to specify k equal 1, k equal 2, k equal 3, until k equal whatever number. Let's say this algorithm, this specific example, I choose k equal 3. You check out the nearest 3 neighbors. This one, this one, this one. Oh, I have a 2 orange and 1 white. So this unknown input should be orange. This is how KNN works. Make sense?
No.
No?
No.
Okay. So let
Known
me go.
nearest neighbor. Okay. K is known.
K is number that you are decide. Either 3, 4, 5. It's depending upon your engineering decision. So let's say I select a 3. So 3 nearest neighbor. I have to check out 3 nearest neighbor, which is this,
Okay.
this, this. And they won, right? Class 1
Mhm.
is more. Orange class is more. So my input should be classified as orange.
Orange. Okay. Okay.
Okay? So let's give me an example.
Okay.
Yeah. So given input xi, find k example that are nearest xi. And use these k example for classification. Use a majority class of k neighbors.
Okay.
Okay?
Majority. Okay.
Yeah. Because it's quite straightforward. Like you have a similar things. Oops. So it's a highly likely this will be orange.
Okay.
Okay.
All right.
So here's an example. there's two types of measuring the waves on your soil. And these black dots are classified as these waves are like detected by nuclear explosions. These white dots are earthquakes because of earthquake. Okay? Now, your new input here, you're checking out the k nearest neighbors. And then if it's a k equal 1, then you can check out the what is the nearest neighbor and then classifying your input data as it is. Okay? So this is the decision boundary of classification of the nuclear explosion, this black area. On the other end, this white area is classified as earthquake. Okay? So give me more example. Now the problem or question is, I just randomly say this is a 3, and this example was what? 1 and 5. What is a good value for k? What is a good number to decide a k? This is the problem in K&N classification. Because depending upon what k number you decide, your K&N algorithm works better or worse. So this leads to K&N underfitting and overfitting issue. High or low k for what problems? So if I say k equal 1, is it underfitting problem or overfitting problem? Let's move on. Something to think. If I put low k, then it's overfitting problem. Okay? Because it's a very, very perfectly classify all the existing data points. But if you have some outliers or noisy, and your input data is so sensitive about those outlier and noisy, as you can see, the decision boundary is very complicated like this. So it's more like an overfitting problem. But on the other hand, if you put IK, right, then it should be underfitting problem. Let's say you have 1,000 data points here. You have 1,000 data points about your earthquake measurement. And if you count down the 1,000 data points, then you will classify as just one majority like data points. But that is really essentially underfitting problem. Everything will be classified as the most frequent class in the whole data set. There's no learning. It just see what was the majority value and predict the majority value. So high K will create the underfitting problem. Okay. So how to avoid such problems? What was the answer? What did I say? What was the most important lesson I should give to you all? Cross-validation. So you have to cross-validate by changing k number, k equal 1 to whatever number, and keep cross-validated and see the lowest cross-validation error. That's how you can come up with the k number. Okay? Any question so far? K&N underfitting, overfitting problem?
I have.
Yes,
Like
please.
in regression analysis, we have that regression coefficient, which we find out how well our data is correlated. But in that case, how we find out we have the lowest cross validation error?
Good
Is there
question.
any coefficient or something?
Good question. So that is going to So, for example, this type of problem, we have two types of wave measurement, and either that wave or that movement or that shake is by earthquake or nuclear explosions. What is the accuracy here? If computer classify earthquakes and actually earthquake, then that's right, right? And if computer says, hey, I think based on this wave, this is by nuclear explosion, and it was really actually by a nuclear explosion, that is a right situation, right? Akshat, are you following with me?
Yes.
Yeah, but what is the worst case scenario? What is the wrong like situation from the machine learning perspective? Can you explain to me?
When majority of my data is either above of the line or maybe the below of the line, under or over fitting case, maybe.
Yeah, yeah. And in other words, like if the shake was by nuclear explosions, but if computers say, hey, this is by earthquake, not nuclear explosion, that's a wrong case, right? So it goes back to the lecture one, which is the confusion matrix. So we need to increase this accuracy, like you said, the coefficient of correlation in your regression analysis. We have to increase this accuracy, classification accuracy using confusion matrix by cross-validation. So the simple answer here is you have to check out the accuracy by confusion matrix, which is a true positive and true negative rate based on your total data. Was it clear?
I think, but the predicted and the actual is like the future observed and the future predicted. Are we are finding the correlation between both? How much our model is accurately predicting these variables?
Yeah, so that is our objective, right? Your regression objective is how your model is explaining the relationship between input and output, right? In classification, your goal is how classify accurate thing, like true positive and true negative. So the accuracy here is really the whatever you are referring in the regression analysis.
Okay, thank you.
Yeah. Okay. So if you are unclear, then we can discuss later on. But let's move on. So any question on KNN underfitting and overfitting? Okay, let's move on. So cursive dimensionality. KNN works well in low dimensional space with plenty of data. For example, if your 2 points are here and here, their distance, you can measure it quite easily and it's not very far away. But if you have this point and this point, and if you have adding another dimension, this point and this point, and if it's a multi-dimensional, like four-dimensional, 5-dimensional space, or high dimensional space here means dimension more greater than 15. The nearest neighbor is very, very far away. And that means it's not informative as it compared to low dimensional space. So if you have so many features, which means so many dimensions, then KNN will not work very well as it works for the low dimensional space. Okay. Here's an example about using the KNN in the building energy domain. So some researchers coming up with Raspberry Pi based robot and then putting some sensors, temperature sensor, relative humidity sensors, and then this like small robot moving around the office buildings and check out the relative humidity and temperature. And then ask people, hey, do you feel hot? Do you feel cold? Do you feel like normally comfortable? Those 7-point answers. And then it is making a decision boundary based on the KNN algorithm to what is the right relative air temperature based on their votes. So in this case, what is a label? What is the output label that KNN algorithm used? The label is the people's answers. Is it hot or cold? Their answers. This is their answers. On the other hand, their input is relative humidity and air temperature. Okay? So based on these inputs, they try to correlate the mapping between input and output. All right? Any question on KNN? KNN algorithm? Anything on chat, Tanner?
No, right now.
No, right now? Okay. Joel, are you good?
Yes, I wanted to know though, the KNN algorithm types, are we just being introduced to them, or are we going to be working them later on today?
We will work on these KNN algorithm using Python.
Okay.
Yeah.
Perfect.
All right. So the next question or next algorithm is a decision tree. And I think decision tree is quite straightforward compared to KNN. So you might say that this kind of decision tree, is it a mammal? Yes or no? People keep it as a pet? Yes or no? Is it farm animal? Yes or no? Bird? Yes or no? Live in the ocean? Yes or no? So that you can classify your input animals. The main idea for the decision tree is figure out which features are the most informative ones to ask questions about, considering the effect of the different answers to the questions in terms of how the domain is split up after the answer is received and the likelihood of each of the answers. All right, let's see. It has root node, interior node, leaf nodes, and each non-leaf node is a tree specified carried out. The descriptive features. Each of the leaf nodes specify a predicted classification for the query. All right. So here's an example. What question would you ask first to coming up with a better decision tree algorithm? Is it a man or does the person wear glasses? I mean, for the better decision tree algorithm.
I think the gender, because it is it because it's less specific?
Okay, good try. Anyone else had different opinion? Okay, let's see together. So the first, if we choose, does the person wear glasses? Yes, no, and only Brian applies into yes. No for 3. Is it a man? Yes, no. 1 versus 2. Do they have long hair? Yes or no? So the average number of question is 2.25 to get. So Brian, you only need a one question, which is a 1. To classify John, you need to ask 2 questions. To classify Afra or Alfe, 3 questions and 3 questions. So in average, you have to ask 2.25 questions. But if I start with, is it a man, like a gender-related questions? And does the person wear glasses? Do they have a long hair? Yes or no? And only 2 for Brian, 2 for John, 2 for each. Then the average is only 2 questions. So from the computational demand perspective, or the most efficient algorithm, or the most efficient algorithm choose the question of gender, like you said, Joel. So this is how, I mean, decision tree is quite straightforward, but how to make this decision tree is based on the information gain that you will having the shorter or average number of questions. Okay? Any question? Okay, so the answer is a 2, the second question. So decision tree is used in building energy domain. So predicting energy consumption by decision tree. Because again, like very first discussion point, there's a large data set is available in our domain in building energy. So we can build up the decision tree to classifying what is high amount of energy consumption, low energy consumption patterns. For example, temperature is high and these HLC, heat, ELA, these are all the building characteristics that you can ask, and then you can build this kind of decision tree algorithm to predict the energy consumption by asking these questions. Outside of this decision tree and KNN algorithm, there are algorithms called support vector machine, logistic regression, linear regression, naive Bayes, ANN, artificial neural network, and many more. Really, people keep adding new supervised learning algorithm in this portfolio. So these are all there for your self-learning. Any question on the KNN decision tree?
I have a question on logistic regression.
Mm-hmm.
Yeah, it's like I mean, I have gone through like some like before this lecture, like gone through some videos and tried to get some idea about machine learning. So the classification thing is clear to me. Whether like for example, with the yes or no, I can understand. But how you can give value in logistic regression, right? Can you just like simply explain how this algorithm works, like in logistic regression?
Yeah, I'll try my best to simple
Yeah.
explanation to you. So it sounds weird. It's logistic regression, but really the logistic regression, what it does is classification of 0 or 1. So maybe that what you refer, what you watched last time, giving that confusion because it name is a regression, but it's 1, 0. So what it does is really logit curve and then draw the logit curve and either that is closer to 0 or closer to 1. And then classifying, is it closer to 0, then it classifies as 0. If it's closer to 1, then it's classified as a 1. So that's the simplest I can try, but I would recommend watching the logistic regression video, or I can send you some textbook that you can refer.
Okay, just one thing, like logistic regression gives like continuous values, right? But like you were saying about like sigmoidal function, right? Something like that,
Right.
right? 0.
Exactly.
Yeah. But how can it give like continuous values from sigmoidal value? That was a little bit confusing for me.
Yeah, let's talk about that after this
Sure.
session.
Sure.
Okay. So what
Sure,
was your name
sure.
again? Let me write it.
My name is Miuru.
Okay.
Miyuru.
Okay. All right. Let's talk about that later.
Thank you very much. Okay.
Okay, let's move on to unsupervised learning. So unsupervised learning is different from the supervised learning. Does not have reference to any label. It is often described as letting the data speak for itself. Okay? So here's a training data set. Before, in the supervised learning model, it says, these are blue labels, or B labels, B labels. These are like A labels. You put labels on the people or labels on the data set. But in unsupervised learning, there's nothing. There's no label like this B or A or B or C, but just input data itself and then see what is the pattern of it. That's the main idea about the unsupervised learning. So one of the famous machine learning professor at U of Toronto says, when we are learning to see, nobody telling us what their might answers are. Instead, we just look at it. And what is the pattern? That's about the unsupervised learning. So when we cluster the observation of a data set, we seek to partition them into distinct groups like this. Partition them into distinct groups. Because when you look at it, when you look this training set, you can intuitively understand, oh, maybe this is a group, this is a group, this is a group, like this, right? This is a very intuitive process, like see the patterns of it. And the observations within each group are quite similar to each other, while observations in different groups are quite different from each other. So you really no need for data labeling, but just see the pattern and grouping them based on their pattern. But now, here's a challenge. No simple goal for this analysis. There's no such thing. There's no prediction rate. There's no accuracy, right? Because what is a label? What is the right answer? We're striving to. So that means it's hard to access or evaluate the results. That's a challenge of unsupervised learning. Okay? Any questions so far? Okay. So here's the original unclustered data, and you can cluster them into like this. And let's say if you want to classify these data into group of 2, then maybe you can try this, right? If you want to group them 3, maybe like this. And maybe you want to do in 4, then I don't know, maybe like this. So this is the main idea about unsupervised learning. So here's a specific algorithm that I would like to explain. It means clustering, and it's a simple and elegant, and partitions a dataset into k distinct, no overlapping clusters. So to perform k-means clustering, you firstly specify your desired number of cluster. For example, k equals 3. Then the algorithm will assign each observation to exact one of the k clusters. So, for example, here, erase it again. You put k equal 3. This is what you need, like your KNN algorithm. Then you check it out, your neighbor's mean value of it. And then you have to classify these points. So these, let's say these green mean value or average value points is here, and blue average point is here, and red average point is here. Let's say your new input is closer to here. Check out the distance to each center points, and this, if this is a shorter distance, then this new point is clustered as green. Okay? So again, we must first specify the desired number of k, then the algorithm will assign each observation to exactly one of the k clusters based on the distance to the center of each clusters. Any question on this procedure?
How we will find out the best value of k?
Yep, how to choose k. That's exactly what I'm going to say. So, unfortunately, there's no single right answer. Nobody knows. Sometimes it is depending upon your problem. So if someone say, hey, how do I cluster the data set into 3, good, bad, strange, then that is you must put k equal 3. Or high, medium, low, then you must equal k equal 3. But there are some indices to capture the quality of clustering. So that's a sum of squared errors, and there's other like silhouette scoring. So there's a couple scoring method, and then it goes down. These errors are going down because let's say you put 10 data sets, and if you put k equal 10, then now it perfectly classified 10 data points into 10 group because it's a 10 individual input data. But what's wrong in here? Akshay, can you imagine what's wrong in here?
No, I'm not understanding.
Yeah, so let's say there are 10 data. Let's say we have 100 data point input data. Let's go back here. Imagine that these all blue dots are 100 data points, number of data points. And if you put k equal 100, then it will perfectly classify these 100 data points into 100 groups because that's all individual groups. But there's no point of clustering that, right? The reason we are using unsupervised learning is we want to grouping them by the certain smaller number. So having said that, if you put the higher number of cluster, let's say k equal 10 or k equal 100 or whatever, then your errors will decrease. But at some point, if you have so many low or so high number of k, then there's no point of clustering that. So some people say we need to use the elbow method. This is a shape like your elbow, like your arms, put it in the somewhere here. And then pick out these elbow plots or elbow spots and then say, oh, 3 is a good number. Or someone say 5, and 5 is a good number. This is related to no free lunch theorem. You have to check out 3 and 5 and see how they are good at it in terms of the unsupervised learning results. No free lunch. Oops. Am I answering your question? So simple answer here is there's no perfect or the best optimizing way to choose a K. It really all depending upon what is your interest. But one index is more k number will decrease the errors, all the indexes. But if we put higher number k, then it's not there's no point of clustering that. So you have to balance by this kind of ELO method, or keep trying and then see the results. Is it clear to you? Or other students, is it clear to you? A number?
Yes.
Okay. So if you can specify which part is unclear in K number, then I'll try to answer it over the break. How about that, Aksha?
It's clear.
Okay, okay.
Thank you.
Few people said yes in the chat.
Oh, okay, sorry. Sorry to see the chat. So Tanner, your role, just tell me, okay?
No worries.
Yeah. All right. So here's some example about using unsupervised learning in the building energy domain. So the main idea about this paper is they try to cluster the building energy profiles and then try to cluster those energy profiles into the shape and grouping buildings by their shapes. So conventionally, we're saying, hey, there's a school building, there's an office building, there's a factory building. That kind of classification is good, but it's not good for the energy distribution system. The better way is building A is noon peak, or building B is A is like morning peak. Building C is like evening peak. If we can classify buildings by their patterns, then it's a lot better in terms of energy distribution system, developing the energy distribution system. So the main idea here is we collect around thousands and thousands and thousands of building energy consumption profiles, which is a daily profile, and then apply k-means clustering, bisecting k-means and GMM clustering algorithms, and then with the increasing by k number 2 to 3 until k number 10. So like I said, there is no optimal way of selecting k. So what we observed here is when we choose k equals 3 and k-means clustering algorithms, then the result makes sense to us from the electrical distribution company's point of view. So that's why we selected k equals 3 and k-means. So this is going back to what Joseph's questions. Machine learning is something skills, but make it this one meaningful is putting your own domain knowledge. In that way, you will use the machine learning purely or completely for your own tasks. So in this case, there's no mathematically find out the right number of k, so we try various things and then choose the k-means and k equal 3. So this is the results of G1 and G2, G3 of the K clusters and compare that with the conventional way of building clusters. And other unsupervised learning algorithm is, like I say, bisecting k-means or dbSCAN method or the GMM method and many more. Okay. Any question on unsupervised learning algorithm? So I think the main key takeaway lesson here is the difference between supervised and unsupervised learning, and that is the existence of labels. And because supervised learning has the labels, it tries to mapping between input and output. On the other hand, unsupervised learning, they don't have any mapping or input and output. I mean, output itself. So it is just a pattern of input data itself. Okay. Let's move on for the reinforcement learning. So supervised learning, you have input and you have outputs and see the labels. And then based on that error, you can train the model. Unsupervised learning, there's only input and see the patterns and show the outputs. On the other hand, reinforcement learning is there's a reward. It's not label itself, but it's a reward, some sort of reward signal to the ML algorithm to train. And based on that reward, not the outputs like supervised learning, but it's just the reward, then it train itself. Let's move on. So reinforcement learning is agent-based modeling. So there's an agent and do some actions to the environment and then get a reward and states from the agent and keep iterating this, then agent will adapt to the environment. And reinforcement learning is getting popular these days and it's its own field. So I highly recommend this book to learn more about if you want to know more about reinforcement learning. It's quite cool method. And you may remember the Pavlov's experiment. So if you ring a bell and give a food to your dog, and later on you just ring a bell and the dog start to savor and ready to eat food. Similarly, if you want to use the reinforcement learning in the built environment, for example, building control, the human gives the signal to the computing agent, hey, your automatic decision was wrong, or hey, your automatic decision was okay. If humans can give this kind of this reward to the computing system or reinforcement learning agent, then based on that reward, it will ultimately learn what you like and what you don't like and take an automatic action for the built-in control. That's the main idea. And reinforcement learning, as I said, agent do an action and get a state and reward, and it keep iterating this train error, and then finally the agent will adapt to the environment. And it is formalized by Markov decision processes, which is MDP. This is a mathematical format of expressing your decision-making processes. So here I explain the MDP in detail. So let's say I have a car and my car can get 3 states. One is good shape, one is not good shape, and one is a broken. Okay? And we can do some actions, either maintaining or ignoring it. Based on that action, you have a reward. For example, your repair decision has a reward of -10 because if your car is broken and repair into good shape, you have to spend so much money. That is -10. Your action of maintain, go to like car shop and maintain your car, that is a less cost, but still -1 reward. If you just ignore your condition, then it's a 0, nothing happened. But if action is ignore, and if the car is broken, then you can get some -2. And then there's some probability between how your good shape ignore going to what conditions, okay? So there's a states, which is the 3 states that we mentioned. Actions, like for example, reward. The actions as your repair or ignore, maintain, reward, how much you spend money, and transition function is the probability between 0 and 1. Now, what RL agent should do in a state? Here comes what you should do for your car maintenance. You want to maximize the expected future rewards. That means to maintain your car in a 10-year plan or 20-year plan, you want to minimize your expense on your car while you're maintaining good condition about your car. So that's exactly same what RL agent does in here. It tries to maximize the expected future rewards or minimize your penalty terms in the future. So in RL problem, you have to define state, action, reward, and probability, and solve these MDP, Markov decision processes, is what RL task does. Okay. So since I have a short amount of time, let's go to the building example. So here's one example about light learn, which is a reinforcement learning based occupant-centric control for lighting. So this is a very conventional light switch, toggle switch up and down, and it monitors the light levels and has some computing in here, which has a reinforcement learning agent. So people use their light switch as usual, but the light learn will learn the adaptive set points and save energy consumption. So it basically monitor how people use the light switches and do some automatic actions to the environment. And if person, occupant, like their automatic decision, then they will stay there just working. That means it's a positive reward. But the person doesn't like the automatic decision by light learn, then he or she will stand up and override the automatic decision. And that is a penalty to give the light learn. And light learn have some labels like supervised learning with reward of the negative reward, and then try to update these for the future decision. So state and action reward is engineering design processes. It monitors either person is occupied the space or not by Bluetooth signal, and either the light switch is on or off, and if indoor light level is dark, comfort, bright, and then the period day is sunset time or sunrise time or midday time or completely dark time. So now we can describe our one day with the 26 different episodic states so that we can calculate the transition probability of that. And now we give the penalty term, neutral and positive reward when occupant is comfort and energy saving for the positive reward, and when occupant is discomfort and energy wasting, then penalty reward. This is some math function. So let me go here. This is the one-day cycle of how light learn works with the occupants. So at 9:30, occupant is unoccupied, and he enters the room, and it was a bright condition, then goes out, then coming in again at 10:40, 10:39. Then it goes a dark condition because of daylight condition, cloud cover. So light learn immediately turn on the lights, go here, and then person just leave the room without turning off the light. So light learn decide that, oh, it's a like negative reward or penalty because it's energy wasting. So it decide to turning off the lights. They go to comfort mode, go in here, and go to turn on the lights, keep doing it. So this is a one-day cycle. And from the light learn, the reinforcement learning agent's perspective, daily cycle, it just play with its occupant. So it turn on or turn off by automatic decision, and how the reaction from the occupants and the predefined rewards. Keep playing this everyday game with the occupants and the light learn agent. It will decide, or it will learn the ultimate policy or ultimate rules to control the light switches to maximize the cumulative reward, which means maximize the occupant comfort while saving unnecessary energy consumption. This study tested this light learn with the 5 different offices, 5 different occupants. And obviously it saved the energy consumption based on the conventional control strategies. This is one of the control parameters. As you can see, until day 10, they're fluctuating. What does that mean? That means the light learn is learning and keep interacting and just occupants stand up and override the system. That's why it keep fluctuating control parameters. But after 10 days, it's kind of stabilized. That means it learned the rule. It learned the right rules to turn off and turn down. But in this occupant B, it has some sensitive on that. But the light learn immediately captured this mood change and then tried to stabilize and learning the new patterns of it. Okay, so that's all I prepared, and it's 1:45. I know it's kind of rushed, but feel free to take a break, and this is a lunch break until 1 hour from now on. But I'm more than happy to have any questions at this point. All right, so the lecture 2 is over. Feel free to ask me any question, or if you don't have, feel free to go for a lunch break. Thank you.
Dr. Park,
Yes.
I had a question about that graph. Because you said like on the right near the end where the orange line starts changing.
Yep.
That has to do with the user?
So these are 5 different offices in Austin, Texas. And this was 5 different people. So at the very first 10 days, it kept fluctuating. And after 30 days, we believe that light learned the rule from these people. But this occupant B didn't use the light learn at the very beginning. But she started to use this weird artificial intelligence after 30 days. That's why it shows some fluctuation here. And light learn, later learn this picking mind on these days. Does it answer your question?
Yes, that makes more sense. Thank you.
Yeah. Any other question? Or everyone gone for the lunch?